These are your Pythagorean Theorem 6B-4 notes. This is all about how to use the Pythagorean Theorem to solve for missing sides. So before I start, let's talk about what is the Pythagorean Theorem. It is a squared plus b squared equals c squared, which is where you take a side, like this, a, square it using the squared button on your calculator, or multiplying it twice. It's different than multiplying it times 2, just remember that. It is multiplying it twice. Times b, or plus b squared equals c squared. This side over here is the c. It is the longest side. It is called a hypotenuse. If we took this number squared plus this number squared equals that number squared, we would be finding out sorry, I don't know what I'm saying. The hypotenuse. Yes, that's what we would do. So let's pretend that we have a here. Let's do, let's give this a 6. Let's give this an 8. If I were trying to figure out the missing number, I would need to take 6 squared, because it tells me to do a squared, so whatever a is, square it, and add it to 8 squared, which is b squared. 6 squared is 36. 8 squared is 64, and if you don't believe me, you can definitely use your calculator to check. It's supposed to equal whatever this line is squared. 36 plus 64 does equal 100. And technically the last thing I would need to do is I would need to square root this number in order to figure out the just plain c by itself without having c squared. The square root of 100 is 10, so c the whole time was 10. The missing number was 10. Let's try to see what we would do if we had to use a graph to find the distance between 2 points. Negative 5, 2 would be this point here. I would go negative 1, negative 2, negative 3, negative 4, negative 5, and then up 2 to draw a dot. Here's 1 dot. The next dot, 3, negative 4, would be here. 1, 2, 3, 4 would be here. If I were finding the distance between both of these points, this might look a lot like rise over run to you guys. But I'm finding the distance, not the slope. Okay, the distance is a very important word. We have to figure out what is the length of this line. And I can't actually just count the little squares because all of the squares that it goes through at different amounts. It goes through at different lengths. So I can't actually count that. But what I do know is I know the Pythagorean Theorem and I know how it works. I know that if I created a right triangle somehow, maybe by doing this, that I could calculate the side lengths to find the side that I was looking for. So since this side length over here was 1, 2, 3, 4, 5, 6, yes, I'm counting the boxes, and this side length over here is 1, 2, 3, 4, 5, 6, 7, 8, and I was looking for this side length here, I would be able to use the Pythagorean Theorem to find the missing side, which is what I just did. I had a triangle that was not on a graph that had the side length of 8, and another side length, or a side length of 6, and another side length of 8. And I figured out that the missing side was 10. So that's exactly what I could have done here. Okay? So again, the formula is a squared plus b squared equals c squared. Now, whenever you take tests, you will be given this formula. You don't have to memorize it, but you do have to memorize how to use it. So some things you need to know is that the longest side is always c. Longest side is always c. That is very important. It is also called the hypotenuse, sometimes called a diagonal. I'm going to break both of those down. And the other sides, A and B, can be either side. It doesn't matter which one is which. A lot of people like to do the whole, like, the smallest side is A, the other side is B, and the biggest side is C. And that's totally up to you. You can always switch the A and the B. They actually don't matter which one these are. It only matters that the side across from the right angle is C, because it is the longest side no matter what, if it's a right triangle. If and only if it's a right triangle. So let's solve another example of Pythagorean Theorem. Let's do let's do 18 and 24. And yes, I made these numbers up, but I already have them in my brain, so I already know what to do. So don't think that it's just super random. Okay, so if I have this right triangle, and I'm trying to figure out this side here, across from the right angle is the longest side of the hypotenuse, which is C. This tells me that I know A and B because A could be here and B could be here. And I just got to figure out C. So if A squared was 18 squared, I could calculate that. And if B squared was 24 squared, I can definitely calculate that too. I still just don't know what C squared is. So you know what, I'm going to go ahead and take it a step further in my calculator and type 18 squared plus 24 squared instead of going one by one. I can just go ahead and do both of them together in the calculator. 18 squared plus 24 squared is 900. But remember, this is 900 equals C squared. It is the square that it was supposed to make. Okay, if I were just looking for the length of the line, I need to figure out what number squared equals 900. I can do that by doing the opposite of squaring, and that would be a square root. Okay, so let's take the square root. Remember, you do gray button and then x squared. 900, and you get 30. Just as a check, 30 squared, or 30 times 30, should give you 900. So that means we were accurate, we were correct. The missing side was 30. All right, let's do one more. It says there is a ladder leaning against a 12-foot building. The ladder is 5 feet away from the bottom. How tall is the ladder? We don't see the picture here, but we're going to need to draw one. So first of all, we have this building. The building is 12 feet tall. We have a ladder leaning against the building. There's my ladder. I'm going to draw my ladder. It's a really bad ladder, but you know, whatever. Whatever works. And then it's leaning 5 feet away from the, oh, my ladder didn't reach the bottom. 5 feet away from the building. I got to figure out how tall the ladder is, or how long the ladder is. So I'm going to use my life skills and realize that buildings stand straight up, so that must make a right angle. And I know that my C is always across from the right angle. So this can be A, and this can be B. I now have 5 squared plus 12 squared equals we don't know squared, which I call it C. 5 squared, and again, I can just type this into my calculator. 5 squared, oops, plus 12 squared equals 169. So if all this together was equal to 169 squared, what can I do to this number to get the end result? The end number, this tiny number here. 169 would be a lot, that would be a really tall ladder if this was a ladder next to a 12-foot building, okay? So you kind of have to use your thinking skills to realize that that is not the final answer. We need to square root this number because that was technically the answer for the square of this side. But we don't have a square, we just need the line, the length of the line. The answer is 13. Here's one more way that you could do these. If you get to this position right here on any of your problems, where you fill in the equation with the missing numbers. This is an equation because it has an equal sign and it has a variable. We just learned not too long ago that if we wanted to solve equations in the calculator, there is a cheat code for it. Menu 3-1. And you can type this equation into your calculator and it'll give you the answer for you without you having to do all the math on your own. So I'm going to show you. 5 squared plus 12 squared equals C squared. And I'm using the squared button. We got to figure out where that squared button is because we're going to use it a lot. Before I press enter, I have to tell the calculator what letter they're finding for me. So I come way down here to the comma button. I press comma. And I'm going to press C, the letter C, to tell the calculator to find C. And whenever I do, it gives me the answer. And it says the answer was 13, which I already knew because I already solved it. But that is also another way that you can help solve Pythagorean theorem.